Okay, so noise is a unwanted sound. Even if a sound consists of the finest music, it can be considered as noise if it occurs in the middle of the night. So, because noise or sound is one of our five senses, we are not able to just off it lah, because you will always be able to perceive it, like our sense of sight, which is light. So by nature means in a normal environment, usually noise is not a problem because we always try to design, or we always try to make anything in just a limitation. Okay, so in a normal environment, noise shouldn't be any problem lah. But when we are living in a city, then we will be able to encounter a lot of different types of noise which will affect our life. So usually in a city, you will encounter a lot of construction project. So this construction project, usually they will be working during the morning, but in rare cases they will be working during the night. So during the night, if they were to be doing any very loud activity, maybe they are digging a hole, they are constructing a building, or they are hitting their piles, then they'll be generating very loud noise which will affect your quality of life. So there are five detrimental effects of noise. The first is the hearing loss. So if you were to be exposed to a noise level, you are to exposed to an excessive level of noise level for a consistent period of time, then you will lose your hearing. So this is only true when you are working in the construction site lah. So if you were to be exposed to a very prolonged period of loud noise, then you'll find that your ability to hear you'll lose your ability to hear. So one of the situation will be construction site. Another situation might be if you're working at the airport. So for those aircraft maintenance people, you always find out that if you're boarding a plane, you'll always find out that those people are always wearing a earmuff. So an earmuff will be something like this. If you were to notice lah, they will always be wearing an earmuff, or in a construction site, you'll be given this earplug. Okay, so the first will be your ability to hear lah, you'll lose your hearing. So the second will be your quality of life. So if you were to live near a developing area, or you are living near the highway, you'll always be encountering undesired noise. So the noise can be coming from, if you are living in a near to a highway, the noise will be coming from the car. So even if the car is not honking, means they are not pressing their horn, by going through the road very fast and very quickly, you will also be hearing this sort of noise. So this sort of noise, because there's no sort of pattern to it, is always considered unpleasant and undesired. But because of the way, because of the environment, and because this is a city, then this is unavoidable lah. But one thing we can do is we have to build our building in such a way that the building is able to absorb this noise. And also because of the way the building is built, we have window. So by closing our window, we'll be able to reduce some of the noise. And then if you were to put a curtain on the window, then we will be able to reduce the voice even more. Okay, so next we have the interference. So interference with significant sounds such as speech and music can be annoying in some situations. So interference is in terms of if you were to do something or you were to have a meeting, and then a noise were to be suddenly generated, means suddenly there's a construction going on your site, on your area. Suddenly there's a very loud construction noise. So this is a interference. So most of the time, interference where you were doing something and suddenly a very loud noise were to come and interfere your daily routine, most of the time is annoying lah. So only in some situation is dangerous. Maybe you were doing something very delicate, and then noise is the noise surprise you and you cause the thing that you are doing to hurt you. So only in some situation they are dangerous, but most of the time, interference of a very loud noise on your daily activity is always annoying. So it's also a distraction and an expense. So distraction is it will cause inefficiency and inattention. So it will distract you. It will cause you a surprise. It will distract you and it will annoy you. So this is what noise is lah. And then finally you have your expense. So the measure needed to control excessive noise are expensive. So business may also suffer loss of revenue in a noisy environment. So because you are unable to shut off our sense of hearing, to you are not able to specifically target noise and say, oh, I don't want to hear this sort of noise. So to reduce the noise being generated outside or maybe during at the site or maybe for a building is very, very expensive. So why is it expensive? Because first of all, in a situation where maybe there's a drum or what, if you want to reduce the noise, you have to install a acoustic screen. Maybe for construction site for this, where they have a machine doing the work which is very noisy, you have to put a barrier. So a construction barrier, something like this lah. So you have a partition which covers the machine, and this will when the sound is generated, this partition will absorb and reflect the noise back onto the machine, so the sound won't travel all over the place. So this is some sort of like methods to ensure that the noise do not travel all over the place and affect other people. So all this sort of additional barrier is expensive. So usually construction won't want to spend so much on it lah. Okay, so as previously, noise is measured in units of decibel, but to measure noise, you have to use the sound level meter. So a sound level meter is something like this lah. I think this isn't very nice photo. So this is how it looks like lah. And in the experiment, I'll be showing it to you. So it's usually a device and then with a mic in front of it. So if you were to shout into it, then the value will increase up and down. And this value shown is in decibel. So the sound level meter is an instrument designed to give a constant and objective measurement of sound level. So if the sound is the amplitude of the sound is very high, then it will be able to shown in this instrument. So the principle of a sound level meter is they are measured by three stuff, which is the variation in air pressure, variation of voltage and amplified and displayed on an electrical meter calibrated in decibel. So this is in decibel. And by the difference of air pressure, how this sound level measured noise is by in the difference of sound pressure, it will emit a different voltage, and with this voltage, it will be able to display the values in decibel. So a typical sound level meter takes a root mean square value of the signal. So this meter can be small enough to be handheld, are supplied in several grades of accuracy. So the more accurate the device is, of course, the more expensive it is lah. Okay, so since we are studying this, so construction site noise is usually where most noise is generated. So the activity on a construction site often generate noise. So this can cause hearing damage to people who are working on the construction site or cause annoyance to the people near the construction site. So noise control is governed by the Malaysian. So it's governed in this Factory and Machinery Regulation 1989. And then also there's also a noise compliance to the respective local council, either DBKL or MPPJ. So for this council, they actually set a limit on when you can work. So the most basic is this lah regulation for noise, which is Factory and Machinery Regulation 1989. But for working, for normal work, usually for construction, you have to apply permit to be able to do any work. So you have to apply your permit, and then in the permit itself, when you are doing any application to the local council to carry out work, usually it's construction work, there will be guidelines on when you can do the work. So usually the guidelines will be usually the guidelines will allow you to work from either Monday to Friday or Monday to Saturday, and doing only working hours 9 to 6 or 9 to 5. So there's a restriction to this working working hour. So if you were to have residential nearby, then you have a reduced working hour lah. So maybe you can only work from Monday to Friday instead of Monday to Saturday. So this depends on the restriction given to the by the respective local council, either DBKL or MPPJ. So if you are at a very high dense area, then the local council will restrict your working hour from Monday to Friday. Although you will be seeing, if you were to live near the construction site, although you'll be seeing the construction is going on, they will still do the construction, but they will limit their noise. They will limit their activity that generate noise only on Monday to Friday, but they'll still be working on Saturday or Sunday lah. So this is the sort of limitation the council will impose onto a construction site. So if you were to one day go onto the construction site, then you will see that they will try to schedule all their noisy activity during the working hour from Monday to Saturday. So just a heads up for you guys to know that construction, if it were to be delayed if it were to be delayed, means it's not able to deliver the project on time, then construction site can be done 24 hours a day, means you have shift. So when a shift happens, then there will be a lot of people in the construction site lah, and a lot of activity being done. But there's always a limitation being put onto the by the local council onto the construction site lah, to ensure that they do not affect the population nearby. So if there's no population nearby, then for sure the local council will not enforce this sort of limitation onto the construction site. So there's a form when a permit is being applied to the local council. So if it is found that on surrounding area there's no residential, then the local council will allow the construction site to work even up to 7 days a week. So local there's limitation set by local council lah. That's to say. Okay, so in depth into the factory and machinery. So inside they specified that no employee shall be exposed to noise level exceeding equivalent continuous sound level of 90 decibel or exceeding the specific limit in the first schedule in the daily noise dose unity. So this is the limitation that to protect the employee being exposed to noise level. So even if you are wearing all these earplug, there's a set of law that the employer cannot force employee to be exposed to. So no employee shall be exposed to noise level exceeding 115 decibel at any time. So and then finally we have no employee shall be exposed to impulsive noise exceeding a peak sound pressure of 140 decibel. So all of this is to protect one of our sense of one of our sense. So because we are unable to turn off our hearing, if we were to be continuously exposed to this sort of noise level or even a very very high noise level, it will actually affect our hearing and we will lose our hearing. So if we were to lose our hearing, then it will be very inconvenient because we are in our daily life as of now in this sort of environment. We need to drive our car, we need to be aware of our surrounding, and this sense of hearing is how we will be aware of our surrounding. So if you do not have hearing, then if a car were to horn you from behind to ask you to move out of the way because you are moving too fast to brake, then they will definitely hit you lah. So our own so as normal, the natural sense of hearing is very very good. So if you were to lose your hearing and you were to use a hearing aid, you'll find that this sort of hearing aid, based on a lot of people's experience being told around, isn't very good because you are unable to adjust the sound hearing of sound. Although you are able to absorb, so how a hearing aid works is they absorb the sound and they are amplifying the sound to put it directly into your ear. So usually hearing sound, based on experience of people telling me, they say that is very noisy because it's not able to do a bit of filtering. So our natural sense of hearing is very good in a sense that if we were to listen to it, we can actually try to filter out a bit of the noise, such as the something like a white noise. So if you were to hear it for long term or some sort of sound, then our brain is actually very smart in trying to filter out the minute subtle sound. Okay, so next off is the noise control action. So in construction site, there's many way to control how noise is being generated. So there's up to about 8 or 9. So the first off is the design preliminary stage. So at the design preliminary stage, elimination of possible noise source before implementation. So this means that if it's possible, we will try not to generate as much noise as possible. So instead of having instead of doing a lot of piling, maybe we can switch to another method which is using pressure. So usually in construction, noise is generated most during the foundation, which is piling. But there's also another method lah. Instead of using a hammer to whack down the pile into the ground, there's you can use a pressure jack, which means a pressure jack which using hydraulic to push the piles into the ground. So all sort of design choices can actually reduce the sound to a very minimal level. So as you can see here, choice of equipment, we have to use newer, less noisy one, or maybe we fit an anti-vibration mounting. So no vibration equals to less noise. The next is the work planning. So some method of working are quieter than others and can be incorporated at the design or working planning stage. So instead of having 10 lorry, maybe you use a different type of material. You only require up to 5 lorry. And then the next is the work practice. So training and education to bring up workers' awareness. So workers' awareness is very important in reducing noise. So instead of the workers simply throwing around the equipment they have on their hand, so in Malaysia, usually the workers is all Bangla or foreigner. So because they are uneducated, so they need to be educated in terms of how they work. So there's always a set way of doing things, but because they want to do it fast and complete the work fast, they will skip a few steps, and this sort of steps will be actually most of the time a bit more dangerous lah than they were to follow the usual procedure. Okay, so the next is the distance and location. So if you were to do your work away from the population, then for sure the noise will be reduced lah. But this is not always the case lah. Then next we have our acoustic screen or barrier. So this is to either deflect or absorb the sound wave. So as you can see here, acoustic screen or maybe a barrier. So a barrier is in terms of so a barrier is in terms of something like this wall, highway wall. So if you were to notice, you were to walk around in KL, you were to drive around in KL, sometimes you'll notice that when you are driving, you have a wall here. And then on the other side of the wall, there will be residential unit, maybe a landed house, a bungalow, or maybe a connected terrace house. So all these wall separating the highway to the residential unit, they actually serve a function to deflect the sound of the highway of the traffic from entering into the residential area. So there's a function to the wall. It's not only to not allow any visual sight from both area, but it serves a purpose to deflect away the sound from the traffic. Okay, so this is about it for the acoustic screen and barrier. So finally, we have our personal protection. So this is usually at site lah. where you are doing a noisy work, so you are doing a work that generate a lot of noise, so you always want to wear earplug or earmuff. So this is so that your hearing is not affected. So if you were to be exposed to a high level of noise for a prolonged period, once you are to stop this sort of hearing this sort of level of noise, you will actually hear a ringing tone in your ear. So if you were to hear a ringing tone in your ear, this is actually you're hearing the noise level at a high level lah. So if you were to keep being in this sort of situation, although you will not lose your hearing, your ability to hear will be affected. So if you were to keep being exposed to this level of noise, then you won't be anymore. Your sensitivity of your ear in hearing noise will actually be reduced, and then ultimately, when you're old, you won't be able to hear much lah. So whenever you are doing anything in the construction, if you were to go there, so always request a earplug if there's noise, if there's a high level of noise activity being conducted. So in Malaysia, previously, if it's an unregulated site lah, means is not regulated much or isn't a very high value project, usually you won't have all this sort of personal protective equipment provided. But when you go to high high profile project, if you go to MRT, then definitely there will be this sort of protection. So Malaysia is improving, but there's still a lot area to improve, because only those high profile project, which is very famous, is taking into concern of all this safety. But if you were to go to those small project where it's something like a house renovation or a renovation of your condo, then if they were to generate all this noise, additional noise by hacking or removing any tiles or concrete, then definitely they are not going to provide you with all this protection. And also, because the workers is not educated, they also do not request this lah, all this personal equipment or personal protection. So this is the usual form of noise control action is that's always taken. So finally, there's this active noise reduction, ANR. So it's an equipment that create an opposite identical wave, half a wavelength out of phase to neutralize sound wave. So sounds very fancy, and there's actually this sort of equipment out there in the market, but there's a problem to it, because you need to analyze the sound wave, and then but after you analyze the sound wave, you need to have the equipment on site, and then but after analyzing the sound wave and emitting the sound wave, you'll actually be able to reduce the sound by a lot. But the problem with this is the equipment is expensive. So usually this will not be employed, and you will not ever be able to see this equipment on site lah. So in construction site, or in mostly in construction site, noise control is a very important aspect for the majlis or even for the client. So sometimes they'll want a report. So a report have to be generated lah for every site to measure the sound level being generated from that site. So to measure that report, you usually environmentalists will be hired to put in the sound level meter at a location, and they are to measure this sound level from maybe 8 to 5 for a few days, and they'll be able to generate a report to submit to the client or the authorities. So with this report, you'll be able to tell that our side is not very noisy. But then because we are in Malaysia, so although all these requirement is a good effort by the local council or the client, usually what the construction industry in Malaysia do is that they will just schedule, because they know sound is being measured, they will just schedule all the activity after this measurement or this is carried out lah. This measurement of sound is being carried out. So Malaysia is very sneaky in that way lah. We know that we are gonna do a report on noise, so we avoid doing any very loud noise activity during this measuring period. Okay, so this is a picture. So I've already gone through again, go through back and forth on it. Don't have to explain much on it. Okay, so there's two types of sound. Either is a sound airborne sound or an impact sound. So an airborne sound is sound which travels through the air before reaching a partition. So airborne sound is generated through voice, radio, music instrument, traffic, and aircraft noise. But impact sound and structure-borne sound is generated through impact on partition of structure. So this sort of sound is what you'll find at the construction site. So whenever you are doing any work, or maybe the workers are hammering the stuff in, so this is an impact sound. So usually airborne sound is always is most of the time is normal sound, except for traffic lah or aircraft. And then usually for impact sound, it's more towards the annoyance and undesired sound lah, because this sort of sound is generated through doing a work, particular sort of work. So this pictures shows how impact sound is being transmitted, which is here. So a sound can be impact sound can be if a person were to do a hammering on top of this floor, the sound will be generated. The sound will be moving through this floor, which is a medium, and then it will move out from this floor. But if a sound will be generated from a speaker, which means they are above, they are not connected from the floor, then they will have to move from the air to the going through the floor and then into the air again. So based on this sort of concept, which is a precast concrete sound wall, if a sound were to be hitting this sort of partition, so once they move from one medium of state from airborne to a sort of partition solid, then when they were to move out of this solid, the energy will be reduced by a lot. As the terms here lah, from 90 decibel, if they were to move through a sound wall, a reduction of 40 dB. When they were to come out from to the other side of the wall, the sound level is only at 50 dB. So that's why you'll be able to see a lot of this sound wall being built. So this sound wall is being built to reduce the traffic noise from here reach the residential house lah from here. So you don't want to hear loud traffic noise during the night lah when you want to sleep, because if your house is on a highway, this concrete sound wall have to always be built so that when the sound is being generated from the traffic, from the car moving up and down, when it were to hit the wall, and then when it were to pass through the wall, the sound will be greatly reduced to a very soft sound lah. So sound move in a in a direct straight line. But because the source of the sound is being emitted in all direction, so if you were to go up to the sky, then it's moving in a straight line, so you won't be able to hear it. Okay, so we have our sound insulation. So in sound insulation, we have two functions. Either we absorb it or we insulate it. So absorption of sound is through the reduction in the sound energy reflected by the surface of a room. So we can do absorption or insulation. So insulation is the reduction of sound energy transmitted into a adjoining air space. So insulation is a principal method of controlling both airborne sound and impact sound in the building. So there's two ways, which is absorption and insulation. So if it's a absorption, usually you have a material which is able to absorb the sound into the material itself. And then reflection is true when the sound is being emitted onto the material, it will reflect back the noise onto the source of sound. So the sound reduction index is a measure of the insulation against the direct transmission of airborne sound. So in construction, a wall is a very good sound reduction material. So you have a lot of composition. Mainly you have your brickwork, you have your plaster, you have your concrete, then finally you have your paint. So all this will greatly reduce the sound being transmitted from the outside into your inside house. So into the inside area where you are at lah. And then window is not a very good sound reduction material. So four factors affect how good the material is in insulating the sound. So the first is the heaviness. So high weight structure with high mass transit less sound energy than lightweight structure. So for example, you have a concrete wall here. If you were to have a glass panel here, then material with a higher weight is able to reduce more sound as compared to the material with a lower weight or density. And then isolation. So discontinuous construction can be effective in reducing the transmission of sound through a structure. So this means that in construction, if you were to discontinue it, you're actually able to reduce the transmission of sound. So instead of having a straight line, if you were to do a if you were to isolate it, so the vibration will only be happening at a single point or at the single structure. And then we have our completeness, so no air gap or area of poor insulation. So when we were to do any insulation, we have to ensure that this is continuous, such as this wall lah. So for isolation case, at the source of the noise being generated, we want to reduce a lot of point of contact. And then finally, we have our flexibility. So no lowering or insulation through resonance or coincident. So because in a window, the sound reduction effect is actually not very good. So to reduce this sound, a double window might be implemented. So if a sound were to be generated and they are to try to cross over from this window, there's a few states in which the sound need to change from. So they need to go across this solid state of the glass, and then they need to be converted and travel through the air again, and then they need to travel again through another glass panel. So once is once the sound go through this few state of material at different thickness, then the sound will be greatly reduced. So another additional formula. So this is how the transmission coefficient is worked out lah. So you have your transmitted sound energy divided by your incident sound energy. So this transmitted is how high the energy is when they are being transmitted, and incident is the source of the, and this incident sound energy is the source energy. So means at this point, at a single point, what is the level of energy? That is the incident sound energy. And then when it were to move from point A to point B, that is the transmitted sound energy. So if you were to divide them together, you will get the coefficient. And then you have your this, the SRI formula. So for a partition, if a partition were to be comprised of three material, so for example here you have your door, you have your window, and you have a brick wall. So the to find out the transmission coefficient for this material, you will have to multiply by the transmission coefficient of the window with the area, and then the brick wall with the area, and then the door for the area. Hence you have this T3 multiplied by A3. And then you have to divide them by the total area. So by using this formula, you'll be able to find the transmission coefficient for any particular composite partition. So example. So this is an example to find out the first part of the formula, which is here. So a wall transmits 1% of the sound energy incident upon the wall at a given frequency. So you have to calculate the sound reduction index of the wall at this frequency. So you are to use the T, which is the transmitted sound, divided by the incident sound. So you're given that your transmitted sound is at 1%, and at 100% is 100 lah. So it's at 0.01. So this is your transmission coefficient. So using the formula, by just substituting that inside, you'll be able to find out that your SRI is equals to 20 dB. So there's a missing one here. Just do a quick update on it. Okay, so the next one is the example 7. So overall sound reduction index. So you're given a wall with an area of 10 meters square, and then it contains a window with an area of 2 meters square. So you're given the value of sound reduction index, which is 50 decibel for brick wall and 18 decibel for window. So you have to calculate the overall sound reduction index for the wall. So first off, you're given brickwork for and also window. So you need to find out what is the transmission coefficient for brickwork and window first. But you're given the SRI, which is the sound reduction index of 50 dB for both brickwork, and for window 18 dB. You are given the total area of brickwork, which is 10 meter square, and a window of 2 meter square. So if you work out, then by minusing out the window, you get 8 meter square for your total brickwork available. So using this formula, because you know your SRI for now we do brickwork is 50, so you have to put in 50 equals to the formula 10 log 1 over T. So by solving this formula for brickwork, the transmission coefficient is 10 to the power of negative 5. So it's at 0.0005. It's a very small coefficient. So this is how you need to follow this sort of step to get the transmission coefficient for brickwork first, and then you do it for window the same method, and you have to use the composite partition formula. So with knowing the transmission coefficient for the brickwork and the window, you have to get the transmission coefficient for this composite material, which is a brickwork and the window. And then by finding out that this composite material is 3.18 multiplied by 10 to the power of negative 3, this is the transmission coefficient for this two combined material, which is one brick wall with a window inside it. Then you have to use back this formula to find out the SRI. So it's a bit of backtracking to find out the transmission coefficient for brickwork window first, and then you have to find out the transmission coefficient for the whole partition, and then with that you'll be able to you will just use back the formula SRI. So you put in the composite material for the brickwork with the window, which is 3.18, into this formula, and you'll be able to obtain the overall SRI for this stretch of brickwork and window. So it will be a bit this is the method to work it out lah. So you can do a bit of practice for your tutorial. Okay, you have your room acoustic. So acoustic principle of the room. So a room acoustic is concerned with the control of sound within an enclosed space. So to provide the best condition for the production and reception of sound such as music or speech. So this one is usually what you'll find in a music production room. So the general aim is to provide the best condition for the production and reception of desirable sound. So there are 5 general requirements. You want to have an adequate level of sound, even distribution to all listeners in the room, and a good rate of decay, suitable for the type of room. Then you have your background noise and external noise is to be reduced to acceptable level, and absence of echo and similar acoustic defect. Okay, so I think there's not much time. I think I'll stop here for today lah. So I'll cover this on the next lesson.